It's often joked that 1980 still feels like it was 20 years ago, but is there a serious explanation for this phenomenon? Both neuroscientists and psychologists have attempted to explain perception of time and differences thereof via biological and psychological mechanism, and there are some theories with a certain traction. However, there is also the question of whether older people do in fact perceive time to fly faster. See the end of my reply for whether this notion can be said to be firmly established. From the biological side, there is the matter of how human brains work. The article shared by you/Gargalito is interesting in this context. Bejan argues that time represents perceived changes in stimuli, observed facts, such as visual images. The human mind perceives reality, nature, physics, through images that occur as visual inputs reach the cortex. The mind senses time change when the perceived image changes. The time arrow in physics is the goal-oriented sequence of changes in flow configuration, the direction dictated by the constructal law. The present is different from the past because the mental viewing has changed, not because somebody's clock rings. The clock time that unites all the live flow systems, animate and inanimate, is measurable. The day-night period lasts 24 hours on all watches, wall clocks and bell towers. Yet physical time is not mind time. The time that you perceive is not the same as the time perceived by another. Why? Because the young mind receives more images during one day than the same mind in old age. His idea is not entirely novel. Both neuroscientists and psychologists have suggested that changes in perception of time with aging may be due to how brain age. See for example Mech in 1996. As a result of the curve-shift paradigm's separation of general performance effects from psychological process effects and the dissociability of clock and memory patterns, it has been demonstrated that the clock system is to a large extent dopaminergically based while the memory system is to a large extent cholinergically based. This work represents a beginning from which a more specific understanding of the neural substrates of timing and temporal memory processes may be gained. A recent study by Soares et al. Found that transient activation or inhibition of dopamine neurons was sufficient to slow down or speed up time estimation, respectively. Dopamine neuron activity thus reflects and can directly control the judgment of time. Marinho et al.'s review of the literature also confirms a relationship between the dopaminergic system and time perception, and there is research suggesting that this system can be affected by age, albeit not in a straightforward manner. See for example Abdulrahman et al. There is also evidence for other age-related changes in the brain which may affect perception of time. Thus Smith et al. Found that, to summarize, with increasing age, time discrimination is associated with progressively increased activation and interfunctional connectivity within later maturing left hemispheric lateral inferior and dorsolateral frontostriatothalamoparietal networks that are known to be specialized for time discrimination, while earlier in life there is greater involvement of structurally earlier developing ventromedial limbic, paralimbic, and cerebellar regions. The findings suggest there are age-associated neural networks of time discrimination with progressive left hemispheric inferior frontostriatoparietal specialization with increasing maturation. That said, according to Whitman, related to this unsolved issue, the question of which areas of the brain process duration has also not yet been answered definitely. Among other regions, most prominently, the cerebellum, Ivry and Spencer 2004, the right posterior parietal cortex, Buetti et al. 2008a, the right prefrontal cortex, Rubia and Smith 2004, Lewis and Mile 2006, as well as frontostriatal circuits, Harrington et al. 2004a, Hinton and Mech 2004, have been implicated as the neural substrates of a potential timekeeping mechanism. Therefore, research suggests differences could be due to age-related neurobiological changes, but there are not yet strong conclusions made regarding the how and where. Psychologist John Weirden has dedicated himself to the topic of perception of time. In his book on the same topic, he observes as you did. In casual conversation, most older people seem to agree that there are changes in time experience as people age, saying, for example, that Christmas comes around quicker every year or that time passes more quickly as you get older. There are obvious questions about what such statements actually mean. An elderly person knows that the interval between successive Christmases remains the same, but somehow it feels shorter than it used to or used to be imagined to feel. In fact, most of the experimental data supporting the notion of some sort of speeding up of the feeling of passage of time with increasing age comes from a method introduced by Lemlich, 1975. Lemlich asked individuals to judge how fast time seemed to pass when they were half or one-quarter of their current age. Most people, even those in their 20s, said that time passed more slowly when they were younger. The average rating of passage of time at a quarter of their present age was about half as fast as at their current age. Given that this was described even by young people, it is not clear that it is a developmental effect at all, as it is definitely not dependent on being elderly. One obvious problem is the question of what people are actually reporting here. Following his review of the literature, he concludes the following. The increased variability may be an indicator of the slowing of an internal pacemaker with age, but this is far from established. Changes in cognitive functions such as attention and memory with increasing age seem likely to play a role in determining age-related effects on timing tasks, but this issue as yet is little explored. Despite popular belief that time speeds up as people age, systematic studies with both conventional questionnaires and probes interposed in daily life find no evidence that this is true. What he is pointing out is the issue with generalizing laboratory results to real life. As he explained in an older interview, "Yes, I'd maybe try and look at the perception of time and the passage of time in the elderly. The scientific literature is a bit confused, but if you get old people into the lab, they're not much different from anyone else. They're more variable and possibly less accurate sometimes. They're worse than students, but they're worse than students at everything. They don't have particular timing deficits. So this thing about time getting faster as you grow older, and people feeling that time drags terribly in their daily lives, is related to things you can't easily duplicate in the lab. It is worthwhile to keep in mind that perception of time is intimately subjective and that our brains play many tricks on us in regard to perception." To quote neuroscientist Eagleman, "Try this exercise, put this book down and go look in a mirror. Now move your eyes back and forth, so that you're looking at your left eye, then at your right eye, then at your left eye again. When your eyes shift from one position to the other, they take time to move and land on the other location. But here's the kicker, you never see your eyes move. What is happening to the time gaps during which your eyes are moving? Why do you feel as though there is no break in time while you're changing your eye position? Remember that it's easy to detect someone else's eyes moving, so the answer cannot be that eye movements are too fast to see. All these illusions and distortions are consequences of the way your brain builds a representation of time. When we examine the problem closely, we find that time is not the unitary phenomenon we may have supposed it to be." Coming back to Whitman. Despite the fact that time is an essential factor for understanding complex behavior, the processes underlying the experience of time and the timing of action are incompletely understood. Too many contradictory theories exist, in psychology and neuroscience alike, that aim at explaining how we judge duration. One could argue that the conceptualization presented here of relating body processes to the experience of time represents yet another alternative approach among so many others. Only future empirical evidence, based on strong theoretical grounds, will tell whether a dedicated neural system actually exists for the representation of time and which neurobiological mechanism causes the experience of time.